problems, they're not short little problems. Because this pretty much is like taking a polynomial function and breaking it down all the way, which is, besides finding the max or the min, that's the only last thing that we could do algebraically with polynomial. So, yes, they're not just quick, short problems, because the larger the power, the more work you have to do. And in this case, we have 1, 2, 3, 4 zeros up here. 1 is at 0. And because it's twice, it's a double root. So that part's important because when we go to write it as a factor, we have to remember that. We have 1 at 4 and 1 at 1 plus I. However, you have to remember something about complex numbers. And Brendan, what do you remember about complex numbers?
If there's one I, there's always another, and it's usually and it's always the opposite, so it's 1 minus I.
Right. You have 2 eyes on your face. You always have 2 eyes that occur together in imaginary numbers.
See, now this
They'll
one's
be
5.
They'll be conjugates. So anytime you're given one of them, the other one is there as well. It's just you might not be given it because that's the part that we want you to remember. Like, do you realize, do you recognize you have one eye, you gotta have the other eye too. And it's the conjugate.
That's a lot
So,
of boiling.
1 plus I, 1 minus I. Even though that 1 minus I isn't given, it's still there. They occur together. Because you're taking the square root of a negative number to get an I. And anytime you take a square root, you always have a plus or minus. Whether you're dealing with i's or not i's, it's still plus or minus. So when we go to write a polynomial function, if x equals 0 is a double root, that means in the equation it should be x squared. And then x equals 4 is really x minus 4. So writing it as a factor, x equals 1 plus I is x minus 1 minus I. I need more space. And then x equals 1 minus I is x minus 1 plus I. You're moving all those pieces so that they're next to x, Brandon.
Could you just simplify the 1 plus I and the 1 minus I to 1 plus 1 would be 2? Or no?
No. Because you have imaginary versus real, and you have to treat them as factors because the way they were created was by creating them as a factor or creating them from a quadratic formula. So it's just like work that they combine together like that. Because the I was created with a square root, the 1 was like outside of the square root, that middle number. So when you multiply these, if you look at your real number and multiply them, so Brandon, x minus 1 times x minus 1.
X squared minus 2x plus 1.
So if you combine those together, Brandon, you're missing that negative 2x in the problem, kind of eliminating that from the problem. And then multiplying the i's, negative I plus I is negative I squared, which is really
Plus 1, so it'd be x squared minus 2x plus 2.
right. That is the quantity that if we use the quadratic formula, we would get the zeros 1 plus I and 1 minus I. So like if you were given this last year when we did the quadratic formula for the first time, you would use the quadratic formula and we would get an imaginary number. So the imaginary number is created by either using the quadratic formula or just solving for x with completing the square. Either one of those work. That's how we get that imaginary number. So this is what we get from the 2 imaginary pieces. Multiplying the imaginary pieces should get rid of the I because complex conjugates give you real number answers. And then we also have the x squared times x minus 4. So you could do this 2 ways. You could multiply the x squared in and make that x cubed minus 4x squared. Or you can multiply the x minus 4 through first and then distribute the x squared through last. It's totally up to you how you want to work through the problem. So that's kind of your call. But this needs to be taken as far as you can go. You need to multiply it out so that you have all the powers of the polynomial up here. So a lot of foiling involved. You foil the imaginary numbers to get rid of the imaginary. And then what we have left are all real numbers that we're going to FOIL again. So the x cubed, it's more like distributing now. So you're distributing x cubed to everything in the back. So Alice, if we do that, we get
X minus 2x
Okay.
Plus 2x.
perfect. And then doing the second number, Alice, would give us
No, yeah, negative 4x 4.
Okay.
Plus 8x cubed minus 8x squared.
nice, you got it. Good job. And then the last step, combine any like terms. Well, we have x to the fifth, and then a negative 6x to the fourth. Looks like a positive 10x cubed, and then negative 8x squared. Questions? So even though there are 4 zeros up there, that fifth one is always there too because they occur together in pairs. So 45 and 47 were similar to this. So go back later and look at 45, 47 and see if you worked through them correctly. So I'm going to talk about 28. And then Brandon, which one of those problems is I like, no, 62 maybe?
69.
So if you look at number 28,
Or 62. Yeah, it was 62. It was 62.
28 says x to the fourth plus 29x squared plus 100. And this one's a special problem because when you look it up in the calculator, what do you notice about the graph? It's weird. Anybody, Libby, do you know?
It doesn't go through the x.
It doesn't go through the x-axis because the y-intercept is all the way up at 100. So that's where it's crossing the y-axis at 100, and it's just going up. Like it's crossing the y-axis all the way up at 100, and it just goes up. It never stretches down far enough to have any x-intercepts. So if there aren't any x-intercepts in the calculator, you can't do synthetic division. It's not possible. You have to have a starting value, some x-intercept, in order to start with this synthetic division. So synthetic division can't work. The only other option besides synthetic division and long division, which are really doing the same thing, is factoring. So if you can't synthetically divide, then you got to go back to the old school way of just trying to get it to break down and factor. Libby, what did you use to factor this?
I did it, I completed this one.
Oh, you completed the square. So if we wanted to just do plain old factoring, Chelsea?
I use x squared plus 25 and then times x squared plus 4.
Yeah, so plain old factoring would give us x squared plus 25 and x squared plus 4. So Libby, you took the 100 to the other side and then did 29 divided by 2 squared. Gave you a pretty rough number.
Yeah.
Yeah. But it still worked.
Yeah.
So then after you have that done, you have both of these factors that you're going to solve for. And in like previous times, we would say that because it's a plus and it's not a minus, you can't factor it any further. But you can still find those x values, it's just they're going to be imaginary. So if we set this equal, we would have x squared equals negative 25. Doing the same thing, if we set that equal to 0, we would have x squared equals negative 4. And then taking the square root of both of those, Chelsea, you ended up getting
X equals plus or minus 5i, and then x equals plus or minus 2i.
So there's still 4 answers, but all 4 of them are imaginary, which only happens every once in a while. Usually you'll have a real number to start with, but in this case, they're just all imaginary answers. That's why the graph looks different. No one crosses the x-axis, there aren't any real numbers. Questions? So then if you, Brendan, did you have a question?
No.
If you look at 62, 62 was a little different because the directions wanted you to use the 0 that they gave you. So it tells you you have a 0 at, I think it's negative 3 plus I. And the original function we're dealing with is 4x cubed, 23x squared, 34x minus 10. So we need to use the given 0 in order to find the real 0. And again, if you have a 0 at negative 3 plus I, Kate, another 0 would be negative 3 minus I. So they occur together in pairs. Can't have one without the other. And it's a lot easier to see with two I's. We got two I's in every problem as well. What can we do with those imaginary numbers to help us find the real answer? Chelsea? Yeah, we can move them with x. And then just like the last problem, we can try and group these together so we don't have that imaginary part in the problem anymore. So foiling them, again, here's x plus 3, x plus 3. Those are the real pieces. So let's foil those together. Those will be our like terms. So, Michael, x plus 3 times x plus 3 is?
Is x squared plus 6x plus 9.
And then the imaginary pieces, those would be the last part. So foiling the first and the last makes negative I squared. So, Michael, this quantity is?
X squared plus 6x plus 10.
Nice. Because that negative I squared turns into a negative 1. A negative negative 1 is a positive. So this piece here, that's the part that gave us the imaginary zeros. If we can take this piece and pull it out of the original problem, then the leftover part should be real. And the way we can pull it out is by using division. And in this case, it's going to have to be long division because this is quadratic. Synthetic division only works with terms that are linear. So we're going to divide this out of the original problem. So the difficulty with this, like the homework, the concepts, is that like you kind of have to look at the problem and like think, what are you given? How does that given information help you break down the problem? So if we aren't given anything and it just says to find the zeros, then you find the zeros from the calculator. And then you'll get the imaginary ones after you use synthetic division. But if they give you an imaginary one, to find the real one, we have to take those imaginary ones and use them to help us get the real one. Yes, you can check your work in the calculator, go for it, check to make sure you have the same 0. But you still need to be able to pull it out algebraically. So we have an x squared, we want to make it 4x cubed, so we would multiply it by 4x, so that gives us
4x cubed plus 24x squared plus 3x.
nice. And then if we subtract all of that, we end up having
Negative x squared minus 6x minus 10.
nice. And x squared goes into negative x squared, negative 1. So that's negative x squared minus 6x minus 10. Subtracting all of that gives us a remainder of 0. But the leftover piece on the top, that's where our real answer comes in. That's the real 0. So the imaginary ones were given to you. We can use those imaginary to create the real. And here's 1 0, here's another 0. So the last one would be 1 4. So it's kind of like just working through the problem in the opposite direction. Usually you find the real in the calculator and you break it down and you get the imaginary. So now this is using the imaginary to break it down to get the real. You can still check it in the calculator. You still have 1 4. That's the only one you're going to see in the calculator because the other two are imaginary. Questions? Like algebraically, this problem is pretty much as far as we can go with polynomials. There really isn't anything else you can do with polynomial besides calculating the max or min. In order to do that, you still need some skills that we have to go through this year so you can do it next year in AP Pop. Questions? Are there other questions that I didn't answer? So, on Monday, we will talk about rational functions, so the horizontal, the vertical, exponentials, we're gonna go over those on Monday. But today, the assignment on the board is a review of complex numbers. So the first 4 problems are just working with i's, multiplying, dividing i's. And then, page 140 would be a review of some of these problems. So using the calculator to find the zero, break it down with synthetic division, getting an imaginary number, breaking it down with a long division, or just FOILing the zeros to find your polynomials. That'll be collected on Monday. I took pictures of the book already in hopes to, because it's like 4 separate pages, and I have the page numbers on the book. So if you have an iPad or an iPhone and you want me to airdrop it to you, I can. But you have 15 minutes, and like in that 15 minutes, you should be able to get some of these done.
Ms. King,
Yes.
are you planning on going to school to get a PhD in mathematics? But the way I did that problem is not looking too good.
Well, I mean, Brandon, like you have to learn.
Failing is how
Don't you learn
succeed.
more from your mistakes?
We're gonna be a net pro.
Oh, definitely. Hey, at least we'll be able to calculate how long it'll take before we pay it off.
You sure about that?
I don't
Oh,
know.
we can, yes, we can.
That's
She
a
was,
fairly
she was
simple-
inferring that I don't know if I'll be smart enough to.
Yeah. Yeah. Brandon, solve that I use synthetic division instead of relation.
Yeah, synthetic division does work too, it's just a little messier with the eyes, but.
Yeah, I tried to use synthetic division.
I use synthetic division, it works flawlessly.
No, it didn't.
I
I like
just
it
have to
better
make,
than what
you
she
just have to make sure when we get to the last one, you're at
No, it's coming.
How did you do it? It went out really nicely.
Oh, yeah,
I got that real fast.
Did you, oh, faster
at
with
the
the
end, and
iPhone,
then
huh?
Uh-huh.
you get really fast.
I don't know, cause it's working.
Yeah, I don't know, I got it, that thing came through.
Yes. I do have the books up here, so if you wanna take a picture of it, because my AirDrop isn't connecting with your AirDrop, but it's 4 pages. But please use this time, you've got 15 minutes, so the page numbers that I'm sending you are, like, you can see the page number, so you know which page number you're working on. It's working, just slowly. Did you get it? Yes. Paper is next to Kayla. Asia, I think yours just went through. Libby, yours came through too.
Yeah. I think that's
Yeah, that's fine, yeah.
Okay, and I have so many pictures of this documentary. I don't understand how many pictures. Like, they didn't buy them.
Yes, ma'am. Alex.
Teacher, are you
Nick, I need you to.
like,
Okay.
Yeah.
You didn't do
You
it, did you?
didn't do the other worksheet.
No,
I'll do the
that's
back.
I'll
you
do
know.
the homework ahead of time. I have the book. Now, you're right-handed. Switch desks.
No offense, but like, his mom, well, we took him, he did me some projects
Okay, yeah.
because I like, he would see like,
Alright, so I'll sit over here. Also just gonna.
Libby, do you like using the
well, it took me a while to get used to it, I guess.
I always have it.
Like my notes, I think I still leave it in my notes. But it's been in my locker since you gave it to us. Like it hasn't even made it to my house. Are you covered in my locker? Notes are done with it.
What? No, we don't look at it. He's still asking.
I would love to see that. I would probably be honest.
I would beat him. He thinks he can beat me.
And Michael.
I was hoping you would. You would pick me over, right?
Why
I just think you would. Exactly. He thinks he can watch over me.
Don't tell him I
He writes it all. No, I used to, if I did this, I would do this ordinance, like, bunch of rare stuff.
Okay, so I would have for,
That's
I just got that.
No, he didn't speak, he did the right.
It said
You
linear.
would've seen my.
So I actually have some writing down.
It said linear, how many linear
This
factors
is
are there?
like all the Germans, it's just fascinating. I like how to break it down, not gonna lie. I just said N factors. He was
I think it's
like,
small factors, but since we're talking about imaginary numbers, I just put that.
yeah, cause I just, yeah.
So if it's plus and
I
minus.
guess I was
that'd
just
be
about
like the-
number three on this
like
one.
about-
Since we're talking about, since we're on the imaginary units, I assume that they're talking about imaginary functions.
So then how do that when it's x? Minus that and x is what?
I just put
Plus,
that.
yeah.
So how you?
Linear, that means you can
Does
graph
the
it.
If it's the same,
So it's the same,
if it's the same as those.
okay.
Yeah.
Alright, whenever they said like,
So that first
whenever
turn.
they said n, I thought, oh, it's imaginary, so n minus two, because they only graph that many. Okay, so it's just,
So like the ones that you're putting graph, that factor
Maybe
is
well
kidding factor up there.
Yeah. alright, I just, okay, I just thought they were talking, I thought that for some reason I thought maybe it was like they like you could graph it. In that case, it would be n minus two,
Okay, correct.
What was it, so there's gonna be two real.
two imaginary.
Two imaginary.
Alright. This interpreted it, but I got, it got that part right.
Thought you understood.
Yeah, but I always knew you always had these other factors that had, that the grades body of
Very cool, little, yeah.